Hello, I'm Andy Peel from the Cambridge Crystallographic Data Centre, or CCDC for short, and in this video I'm going to tell you about how you can use the Cambridge Structural Database in your literature searches and reviews. Did you know that the CSD is one of the largest databases of chemical information in the world, with over 1.3 million entries? And did you know that it's easily searchable in several different ways, including online? If the answer to either of those questions is no, then watch on. So, what is the CSD? The CSD is the largest of several crystal structure databases. It includes small organic molecules and metal organic compounds, whereas other databases cover different types of compounds like biomolecules. Structures in the CSD come from a variety of sources, including journal articles and patents, and each entry is checked and annotated by experts at the CCDC to maximize the knowledge available and to ensure that the data is discoverable. The curation process ensures high standards of quality, and this is a major reason why you should consider using the CSD in your work. There are many different types of chemical compounds in the CSD, ranging from drugs to catalysts to framework materials and more. The CSD is created and maintained by the CCDC, and the CCDC also provides software and services to search, visualize, analyze, and extract information from the data. One such service is WebCSD, the online portal to the CSD. It allows you to view and retrieve structures as soon as they are added to the database and facilitates basic and advanced searching. Let's see this in action. You can find Access Structures, which is the basic online searching interface, at www.ccdc.cam.ac.uk/structures. There are numerous fields that you can fill in depending on what information you have available. The Identifiers field is if you're looking for a specific database entry, so we'll skip this for now and just do a compound name search. Let's say you're interested in nuclear energy and would like to find out about the latest research on thorium chemistry. Start by typing thorium into the compound name field. Then we'll set the publication year to 2025 so that we get the most recent results and press search. The search returned 17 hits in this instance. It may be larger if you try this at a later date yourself. Notice that each hit has a 6 to 8 character database identifier, which we call a ref code. The text part of the code refers to a chemical compound, and the extra numbers, if present, indicate different instances of the same compound, for example a different experiment or a different structural form. The summary also gives you some information about the crystal structure and, importantly, a reference to the journal article and a DOI link to take you straight there. In the case of HUNCOM, this paper actually looks at several other actinide compounds, so it might be a good place to find other interesting compounds. If you want to get more information on specific search results, select them using the tick boxes and press View Selected, or for a single entry, just click on the ref code. You can download the deposited data from the Download button on the left-hand side. The file is in CIF format, which you can open in external viewers such as Mercury if you want to, or you can just study the information in a text browser. There's a 3D viewer where you can study the structure in more detail and take measurements, and a 2D chemical diagram for reference. Underneath you can find lots of useful information about the compound, including a data DOI, which allows you to cite a dataset even when it isn't published in a journal. Scrolling down, you can find details about the crystal and experimental details. These could be useful if you're actually considering making something similar. As you can see, there's a note about this compound being air and moisture sensitive, which you might need to plan for. If you want to do more advanced searches based on structure, formula, and unit cell, the functionality exists to do this, and it will allow you to be a lot more specific about the type of compounds you're interested in. Note that you will need a CSD license to access these features, whereas the simple search feature does not require a license. If you want to learn more about how to use WebCSD, we recommend trying our on-demand module, or you can check out the resources in the playlist and linked in the description. If you want to use the licensed features, you might already have access over your institution's network. If not, ask your site administrator to provide IP addresses to the CCDC. Alternatively, you can create a CCDC account and activate WebCSD following the instructions. You can find technical support from our website or contact us if you can't find the answer you require. If you want to find out about other methods for searching the CSD, including through the desktop software conquest and programmatic searching with the CSD Python API, have a look at the extensive range of training resources on our website. In summary, we have seen how the CSD contains a wealth of knowledge and that it's easily searchable, allowing you to retrieve relevant literature quickly and efficiently. And we have seen that in action using a WebCSD search to find the latest research on thorium chemistry. We hope that you found this video useful and that WebCSD proves helpful for your work. Thanks for watching, and don't forget to subscribe to our YouTube channel.